Hey everyone. Can you all hear me okay? All right, awesome. So great, it's really awesome to be here. Just a quick introduction. I'm Alex. I am the API lead at Sechs Wunderkinder, working on the new version of Wunderlist, which we just announced. I'm happy to say that the role is much more organization than management. I'm also the author of the Koala Gem, which is an SDK for the Facebook API. Also, scavenger hunt enthusiast, which is really neither here nor there, but you can ask me about that sometime. And I'm going to talk to you today about APIs. And just for clarity, I do not mean Apis, the holy steer of ancient Memphis, but rather application programming interfaces. I think it's not controversial to say that APIs are important. We are increasingly writing interfaces for both first and third-party apps, whether those are web with a framework like Ember or Backbone, or native apps with Ruby Motion or for Android or whatever. We're less often writing the kind of Rails generating HTML, which then talks back to Rails, and more often writing applications that communicate with client applications that are actually displaying what the end user sees. Given that, I think it's pretty also obvious and straightforward to say that building a good API is pretty critical. You want to do that right. As a side note, when I say API, I'm talking about an HTTP-based REST API, and in particular Rack and Rails, though I think that a lot of this would be applicable to other types of interfaces as well. So let's start out by thinking, what exactly is the problem that I'm going to be describing in this presentation? And I'd like to take a step back, because we spend our time writing Rails apps or other Ruby apps, kind of creating the insides, the logic, the controllers, the models, and so on. And the API is this thing that kind of exists, that's exposed at the edges, that we put out there but don't really think about as much. And I'd like to take a step back and think from the perspective of somebody outside, whether that's your Objective-C developer, whether that's somebody writing something against your API for their own product, and look at it from their perspective. And for that, we'll take a look at something that I'm rather familiar with, Facebook. Just out of curiosity, how many of you had a chance to work with the Facebook API? And how many of you love working with the Facebook API? Yeah, there's one over there. I'm somehow not surprised. So things start out well. The Facebook API is actually pretty straightforward. You're like, get me, and then it gives you some information. Just a well-formed JSON object. Or you want to create something, so you post to /me/feed with some information, and you get back an ID. That's pretty straightforward. There are other things you can do, like get me feed or get me photos. The organization sort of makes sense. And for doing basic things, everything is happy, life is good. But let's say we're doing something a little more complicated. I used to work at a social marketing agency doing apps for large brands, and a lot of those apps, they may be a contest, they may be something to do with alcohol, and they need to be restricted. So for our example here, let's say this is something that needs to be available only to US residents who are over 18. I think this is something that many of us are likely to encounter, but this is also not the only API in Facebook that behaves the way I'm going to show you. So Facebook describes the app restrictions API. Basically, you just post to this URL with some restrictions parameter. So great, let's do that. You post, you say restrictions, age 18+, because we're just going to start with age, and then it gives you back true, which is not particularly descriptive, but it looks like it worked. And then, we want to just make sure we're new. This is the first time we've done this. So we go to get it, and nothing. Facebook told us it worked, and nothing happened. That's a little strange. So if you go back to the documentation, it does say you're supposed to post a JSON object. And so this is perhaps sort of more my fault than theirs. It's a little unclear. The example, they only give one example that's really basic. But so let's try doing that and actually giving a JSON encoded value there, even though the original value we posted was a totally legitimate HTTP post value. And again, we get true. This time it worked. So there's probably some reason they did that. They could have documented better. But it is there. We've sort of figured that out. We're a little annoyed, but we got it working, and we feel like we can move forward from there. So now we're gonna if we can post and successfully set restrictions using that way, and we can successfully set the age, then in theory we should be able to successfully set the age, kind of location age matching, which is not a particularly well-described API, but there's no reason to believe that this would behave any differently. And it does. And it does in a really frustrating way by just telling you false. Not false, you misspelled something, or false, US isn't a valid location, or whatever. Just false. I'm not going to spend the 20 minutes that it took me, preparing. I've done this before, but it took me 20 minutes preparing for this to figure out what it actually was I was supposed to do. The answer is this. You have to double JSON encode. You have to JSON encode the value inside the JSON encoded value. We're heading into Inception here. It makes no sense. You're just oh. This is the only place age distribution is mentioned in all of Facebook's documentation that I could find. So, this is not something this is not some mistake I made. This is just, wrong. And this is also not, as I said, not the only place in the Facebook API that behaves like this. There are other calls that also require and don't document similar behavior. So at this point, after spending hours on this, you're frustrated and you're like, this is not good. We're not happy. And so, but the question that kind of comes up is why? Why would an API sort of end up like this? And as I said before, the Facebook API is actually really well designed. The fundamental pattern to it is quite stable. I know because it means that I've had to do very little work maintaining Koala, because as they add new features, they just fit into the existing methods. And they may well have had good internal reasons to require this behavior. So kind of what is it that's gone wrong? What is it that made everybody put their hand down when I asked if they love the Facebook API? And I would submit that APIs are interfaces. We don't think about it. We just say API, but they're interfaces. They're a mechanism for interacting with the system. And kind of like all interfaces, they should follow certain principles. And in particular, in this case, you could say the principle of least surprise, which is that your interface should behave as expected by an end user. They shouldn't be surprised by what happens. I shouldn't be surprised by getting a crazy error message or by having something that works in one case fail in another. Whether or not, you could even say whether or not it's documented. Even so, it's still confusing and unexpected. People expect consistent behavior. They want to learn patterns. This is something that the iOS framework, or that the Objective-C frameworks do really well. They are, by and large, consistent. As Tamer said, you understand one pattern in one place, and you kind of understand how it works overall. And you can think of your API in a way as if it had a visual theme. Or you can create that analogy. You don't want your API to be kind of the JSON equivalent of some hideous form that gives you a weird and confusing error message. This is a system I used to have to work with, and I hope none of you have ever had to deal with. So as I said before, one of the things that's really valuable is putting yourself in an external developer's shoes. Even if you're just writing an internal API, Just thinking about it as if you would not know anything about the internals can be really valuable. Because like a friend at Facebook acknowledged that bug, and he said, well, the key thing he said to me was that let's see if anybody has the energy to fix it. These things can be hard to fix. It takes extra effort to make sure that they don't come in the first place, but it pays off over time. And to me, that idea of kind of extra efforts to keep things really good, to keep things really clean, reminded me a bit of code smell. The concept of keeping an eye out for the things in your code that aren't technically wrong, but that may represent deeper problems. And so I'd like to think of this a little bit like API smell. The idea that there are things that are not technically wrong with your API, like Facebook's API, if you know how it works, does what you expect it to do. But there's still signs of problems that could represent problems in how it's, or at least inconsistencies in how it's implemented, that could come and bite you later when you're refactoring. But it's also a problem, I would say, if your API is just hard to use and if people don't like developing against it, whether they're internal or external. And a couple of signs of say, API smell would be differing approach to parameters, like what we saw where some parameters didn't need to be JSON encoded twice, some did. Or unexpected responses, like false, or bad or missing error messages, like false. This is not a complete list, but it's kind of a place to get started. One of the things about API smell or API design problems is, as I said, we spend most of our time on the inside writing the code that exposes the API. So problems with the API are often kind of invisible to us. We rarely, a lot of the time, consume our own APIs. At best, you're writing a request spec, which really doesn't count. And even if you do know it, you know it too well. Like you might know, well, because of this, how these methods or process the results, I know that I have to double JSON encode this. You don't think about that, you just do it, but it's something that nobody on the outside would have any knowledge of. And so that brings us to the question of, what can we do about this? If you're writing an API, how can you kind of try to keep it clean? How can you fix problems that are already there? Much as I would love to say just rip everything out and make it clean, APIs are promises to your users, so you can't just go in there and change them from day to day as you feel like something is better. It really is best to try to do it right from the beginning. Though obviously you can change it over time and fix it, and I would encourage you, if you have an API with problems, to do that, obviously. So now let's step back into our developer shoes and think, what are the things that I could do when I'm writing a Rails app to keep your API clean? This is something we just, as I mentioned Wunderlist 2, we just started a whole new backend for our task management software. And these are some of the things that we've been keeping in mind as we've been going from day one. And one of the first things is really to centralize as much as possible. If behavior happens automatically, you don't forget it. And this fits really well into just general principles of keeping your code dry. And so what I'm going to focus on is basically the request and the response. Managing consistent input across your app, providing consistent output. I'm not going to talk about the big, broad principles of API design, like hypermedia or REST or kind of these other areas. Those differ a lot depending on your problem domain. Whereas avoiding something like what we just saw is pretty universal. So I'm going to tell this kind of as a story. I say I'm an API client, and because I felt like having an abrupt shift in presentation theme animal, we're developing a social networking site for cats. I believe some actually do exist. And let's say our story is simple. We have a user who wants to get a certain number of updates since the last time they synced, to get just some basic data because they're, say they're roaming in Spain, and to receive JSON. And so the first part, getting just a certain number of updates since a certain period. And that's really a question of providing consistent access to the data. How do you consistently allow people to get a certain amount, handle these very common parameters that ultimately translate into database calls? And I would say that this approach, having something like this in your controller, is not ideal. You have one, two, three different queries that that exist, and that would have to be in every type of controller that you expose. Sooner or later you're going to forget something. As extra code that's going to create extra maintenance work. If you add something new, you're then manually going from controller to controller to add this, and you risk inconsistency. One thing that we've done at Sechs Wunderkinder is consolidate everything into a single set of criteria. We call it standard criteria. You could call it whatever you want, but the key is that you just blindly pass in the parameters you get, and then it constructs a scope that's consistent across all your database calls. Here's some pseudocode. It's more Mongoid-ish, but the same approach works in Active Record. Basically, you'd say, if the parameters that the user sent me include something like since or whatever you want to call it, you update the scope accordingly. If it has some IDs, you update the scope accordingly. And given this, you then don't have inconsistency. All of your endpoints will behave the same way. They'll all expose these options. If you needed to parse your restrictions or parse some complex input here, you could do that as well, and then it would behave the same everywhere. This is nice because it's easy to maintain. You have only a single piece of code. And then everything that's consistent in everything, it works in both Active Record and in Mongoid. The con, of course, is that something like this has to be added every time you make a database call. But I really can't think of any way around that. There really isn't any point that both knows the current state of the controller and is central to every single database call. If anybody does, I would actually really love to know. So the second part of our story is sending back the data to the user. And this is really, how do you provide consistent control over the output that a client receives and ensure that you're sending them what they want? And this is the most Railsy part of the presentation. I'm going to take you through a quick tour of render. Render in Rails is actually a very stable method. It has the same signature since 2.3 going into 4. And I've been told that it is going to be staying stable. And basically, render takes your arguments, combines them into a hash, then passes that hash to your renderer, whether that's active model serializer, whether that's what Rails builds or Rails provides, whatever. It also has complete access to the user's state, since render is actually just a controller method. It has params, it has the current user, and so on. This is render. It turns the arguments into a hash, as I said, and then passes that hash into the renderer. So again, what we want to be able to do in this case is to send different data for different devices. Our serializer should handle all the contents. The API should just be exposing these options. And here, in kind of pseudocode, is how you could implement that. Basically, you sort of override render, where you prepare the options hash the way render does, and then you can add your own options that then become universally available. So in this case, you could say data set. Full would give you everything, all the comments, all the friends, whatever. Compact might give you only the most basic things suitable for a list. But the key is that when you then call super at the bottom, that option is available to you as JSON. It's available to Active Model Serializer, whatever. In fact, Active Model Serializer does something kind of similar to provide access to the current user in your serializer classes. So that gives you the ability to do that, and you can actually do more. You can expose the current user even if you're using Rails, which is really valuable. If you're serializing a user object, you may not want to send the email back if somebody else is looking up that user. You could even do something a little crazier like validate that every record about to be serialized can actually be seen by that user. There are a number of different things you can do with this, and there's a bunch of code and pseudocode in the appendix when I post this that covers things like that. The last part of this kind of very quick overview I say receive JSON, but really what this means is kind of managing global behavior, making sure that your app sends back consistent output no matter what you get, whether that's making sure you only send back JSON even if your app crashes, or any of the, adding the right headers and so on, so the clients kind of always get what they expect back. Here, one question is always, can you simplify it? The fewer options you have, the less code, the more stable and consistent your API. So for instance, we made a conscious decision to only do JSON, to not accept regular or non-JSON encoded requests, to only have one authentication scheme and so on. And in these areas, things like Rails and Rack are your friends. I'm not going to go into a lot of detail because I think this is pretty straightforward. The important thing here is whatever you're using, whether it's Rails or Sinatra, whether you're using middlewares or filters to control this global behavior, that you actually decide on it and ideally document it. Like, you should document and decide on every aspect of your API that a client might need to know about. You don't want some clients sending you UTF-16 and then being confused by why it doesn't work because you didn't think to look at that or think about that. And the documentation, as always, does pay off in the long term. So those are kind of the main points. I'm going to throw in 2 quick bonus chapters based on our recent experience working on this new API. One is mobile optimization. Like Facebook, we've encountered the situation where you have mobile clients who really want to save connections, who want to be able to do multiple things at once. For instance, coming out of, you've been on an airplane, you do a bunch of offline actions, and then you ideally don't want to make 30 connections to do something. One solution that I've often seen is a batch API, which is a really cool approach to be able to send multiple operations at once. But one of the main ways that you could approach this would be to add a special batch endpoint that takes a different format. This is something that DHH proposed, basically a batch create controller action. But to me, that feels like you're creating a whole new interface, a whole new way of sending data, a whole new way of receiving data, and very probably new code in your controller that does something slightly different from the regular action. The approach we've chosen, and that is inspired by Facebook, is actually to make the batch API RESTful. That where you basically send in a set of regular calls just described with a URL, a method like get or post, your parameters, and you process them just like regular calls, returning one result. The advantage of this is that it is by definition uniform with the rest of your API because you're really just using your regular API. The clients don't have to know anything different other than, instead of sending the call directly, just describing it this way in JSON, sending it. So here's an example to change themes again. To say we've got a restaurant website. You send get, post, delete, whatever, and you get back a single response that just describes what happened. And this way, you don't have to have extra code. You don't have to have extra options. The people who are writing your clients have to know less. The last point I will make before I wrap up is a suggestion. Especially if you're starting a new API, build a sample client, a reference implementation. It could just be a simple command line or even just a simple library in Ruby. But whatever it is, it makes you a consumer of your own API. It's a way that you can both tell your clients how you expect it to be used. You can use it to test your API really easily, both performance and correctness. And it also gives you a bit of a warning if you do something wrong. So to go back to that Facebook example, this is what Koala looks like. You can ignore kind of the top lines, but this is what Koala looks like for setting app restrictions. And it's already actually a little complicated because of the JSON encoding thing. This is actually a bug that I need to fix. This is what it ought to look like. You have these extra lines that handle a specific parameter that, to me, that seems overly complicated and would be a signal that perhaps I'm doing something a little unexpected, a little overcomplicated. And so kind of just to wrap up, whenever you're doing these things, just remember, whenever you're thinking about the design of your API, remember that you wrote it. So you really have to think of what would it be like to not know anything about it. In my experience writing APIs, you often take for granted that somebody's going to know why certain behaviors take place, which they wouldn't know unless they'd also been developing or at least reading your Rails code. So in final summary, treat your API like an interface and aim then for it to be consistent and predictable. And yeah, think as if you were coming to it for the very first time. If you do that, things will be happy. And I've wrapped up a little early. If you guys have any questions. Yeah.
What is your approach to API versioning? Do you version the API as a whole, different parts? When do you change the version?
So the question was, how do you approach API versioning? That is a little bit on the kind of broad API questions. API versioning is really tricky because it depends on actually a couple of things. What you're changing, who your users are. Like if you just have internal users, it's obviously easier to do a big change. One of the things that Facebook does that I really like, but may not be applicable as much to internal applications, is they have migrations where you can say, basically you can have an option to do, you'll return something in format A or format B, and you can choose for a certain period of time which you want. And then later they default that migration on, and later they remove it. I really like that approach because it gives you the flexibility to test in a sandbox. It gives you the ability to do very small incremental changes frequently without having to create a whole new /v2. But it is more work, and it's a little less applicable for it's harder for a fast changing, especially internal API. In short, there's no magic bullet there. And we haven't yet hit the point where we're versioning our API, so we don't yet know our canonical answer. This one? No.
So I've heard this saying that
You should be lenient on what you accept, but strict on what you output from your APIs. But here you advertise that we should be strict on what we accept too. So what will be the benefits there?
Well, I mean, you don't necessarily have to be. I wouldn't say that, that is a good point. We've chosen to be strict on what we accept because we're accepting something that's very common, which would be JSON. All modern browsers and all clients have the ability to format JSON. But there are certain requests that are hard to construct in, say, just a regular HTTP post. But yeah, but I think as long as you're clear on what you accept, I think the most important thing is not necessarily to be strict, but to know what it is. So you wouldn't want to just leave it totally wide open and let people, you should tell people clearly with examples what it is. Like you can send regular posts, you can send JSON, you can send message pack, but here's how it should be constructed and here are examples.
Yeah, thanks for your talk.
Oh.
It was a really nice talk. Concerning that question, I think the most important thing is to be consistent rather than whether you're strict or not. And so one question, why did you not use HTTP pipelining for the batch requests? Because HTTP actually has batch requests.
Yeah, no, that is a very good question. Not all, we mainly chose not to do that because not all clients that we're working with have easy support for HTTP pipelining. That is a totally legitimate way of doing it, but the use case a lot of times would be that not that we want to be able to make serial requests, but that we want to just send a bunch of stuff and have it be processed and sending the minimum possible amount of traffic.
Yeah, because the advantage obviously if you use, say, HTTP pipelining is that it works with anything intermediate quite well, like HTTP caches, etc. Okay, but fair enough.
No, and that's a good point, and the honest answer is I can't say, we did discuss it, but I can't give you a good reason why we didn't.
Okay. And Do you do any documentation generation from your APIs?
We actually sort of go the other way around. One of our developers wrote a format, and I didn't have time to include this, but one of our developers wrote a kind of system for doing executable documentation, where instead of generating documentation, we actually, in a certain format, describe the requests, what they should look like, and then the expected response. And those can actually be then executed via a small node program, and then be marked with whether they pass or succeed. And so that's what we're using to validate that the API is actually behaving in the way it works, and it gives us the advantage that the people who are looking at the documentation can see if it's actually working. And if something's not working, then they will know immediately it's not them, it's us on the API side. Yeah.
I like your proposed solution about batch processing. Can you describe how you implemented that in Rails?
Yeah, it's actually implemented. There's a gem. It's in my GitHub it's one of my GitHub repos. It's called Batch API, and it's basically a rack middleware that gets the requests, processes them all into operations, and then executes. Then prepares the request environment appropriately, which is the ugliest part, and then just simply executes them all. At the moment sequentially, and then just captures the results and then sends all that back down the stack. One of the things I want to play with at some point in the future is seeing if you can parallelize that if Rails is running in thread-safe mode. I haven't played with that at all, but I'm curious.
That could be a great addition. Though, if some operations will require...
Exactly. You'd have to introduce dependency management, which is something... So like right now, the gem actually requires you to specify that it's being sequentially processed, so that in the future, you could be able, if your client could do that, to turn that off and then specify with some dependency management formula that I haven't actually thought of yet.
Thanks.
Okay, I'm afraid we're running out of time, so... more questions for the party? Okay, so
right,
thanks,
thank
Alex.
you.